Hi, everyone, and welcome to the MLOps podcast. I am Dean, your host, and today I have with me another person with a great name. This is Dean Langsam. He is
Hey,
also a data scientist at SentinelOne, where he works on machine learning applications for cybersecurity. Before that, he worked as a data scientist at Bluevine. He is the creator of an open source project called Dove Panda, which is an overlay for pandas that automatically gives you hints and tips on how to properly use it. He holds a master's degree in industrial engineering from Tel Aviv University, where he conducted research using data science to explore vaccination patterns for whooping cough. And he is also a prolific public speaker and internet celebrity around data science, machine learning, and technology, one of the organizers of PyData Israel. Now, a little known fact is that Dean here is one of the reasons this podcast exists. So he basically pushed us at a very early stage to do something like this. And so I guess we get him to thank for having him on. And one of the things that he philosophically pushes for is that podcasts should be casual conversations and not 60-minute interviews. So we'll try to make this as informal as possible. Be prepared. And yeah, Dean, say hi. And I don't know if you want to add anything to the introduction.
yeah, with this kind of introduction, I should come here like every week. So thanks for all the kind words. I do work in SentinelOne. Uh, Dove Panda is a package that I really like. I should maintain it better. Currently, it only supports older versions of Pandas. I hope to get the time to work on that. And about PyData, we're closing the CFP next week. I'm not sure if this is coming out by then, but also we're looking for sponsors. The event itself is on December, so you have the time. But I welcome everybody to check our website, PyData Tel Aviv. First time it's happening as an individual event, not combined with PyCon IL. It's going to be great, I believe.
I believe it as well. I guess for the announcement part, this is relevant also for non-Israeli speakers, right? Like this is if people are living abroad and want an excuse to visit Israel, they should also submit.
Yeah, we don't provide travel, but if you get in, we'll be happy to have you at the conference. Talks are in could be made into English. Actually, we encourage the talks to be in English, although we have some Hebrew track if you're also a bit shy and you do live in Israel.
So you're covering all your bases. So I guess
Yeah.
starting from from a question so that we can get into it. But you, one of the things that I like about speaking with you is that you sort of have this really varied experience when it comes to machine learning. You also sort of are a polymath. I don't know if that would be the right word to use here, but you know a lot of things about a lot of things. So, from all of the fields of machine learning that you've had the opportunity to work on or experiment with, which one is the best and why?
That's a tough one. What the question is, how do you define the one field of machine learning? Like as we've seen in the past few years, like everything is everything, or as a movie I've just seen, everything everywhere all at once. And even specifically now, you could have said, I don't know, 2 months ago, you could have said we have tabular data, we have transformers, like we have CNNs for images, and then we have I don't know, LSTMs for language. And then we got transformers for language. Then we got transformers for this, transformers for that. So now everything is everything all at once. So I'm not sure would you define the field of machine learning um, specifically. And when we talked about it like a few minutes ago, unrecorded, um, the question if the question was what is your best problem in machine learning, I've written myself a note, and that would be Titanic. Like the first Titanic question intro in Kaggle because I think most problems, like we do like to talk on podcasts about like the cutting edge technology of images with text, DALL-E 2, GPT-3, and everything like that. But most people, most data scientists, even not the upcoming ones, even senior data scientists, are doing problems like Titanic. Like, give me a real world problem that I could actually get into real business values. And people are sometimes shy about having like they're thinking, well, I could never be as good as this person because this person is done. I don't know, he created GPT-3. But most machine learning problems are taking an old business use case and just doing like simple machine learning that you can do after like 2 university courses, apply XGBoost, apply some decision tree. There are many business use cases that could be solved by that and actually get value into the hands of not machine learning people, like actual people to actually use in production or in business decisions. And every time that I get excited about like a new thing in deep learning, but then I go home and I just do like this some problem that could actually, I don't know, increase some revenues to something. Like actually, my wife's works at like a convenience store, and I once told her like maybe get me all the data of all our like the regular customers, and let's try to do like the most common basic recommendation system. I actually never got to do so, but like I get excited by that as much as I get excited by seeing like some talk about like a new innovation about something in transformers.
Um, the best way to dodge that very hard question that I threw at you. So good job. I think that you make a good point that um, it's not completely overlooked, but it's definitely not getting the amount of spotlight hours it should be, which is the whole point of this podcast is called the MLOps podcast, and the tag name is sort of a discussion with industry experts about getting models into production. But the whole point of getting models into production is to provide value in real world use cases. And more often than not, the simple solution is better than the complicated one because it gives you more time to iterate, shorter time to value, shorter time to market. So it's also a competitive advantage if this is sort of a competition. Um, and and yeah, there are a lot of good memes, and a lot of influencers made their name by joking about XGBoost being the best model of them all up till today. So I think there is definitely a lot of truth to that, and it also relates to the whole point of um, the first part of every machine learning project being understanding the problem, the data domain, the business domain. Like, what the hell are you trying to do here? And then the solution is should be an afterthought. And like many other fields, again, I had a similar discussion earlier today, but like many other fields, if you start from a solution and then look for a problem, you're headed for a world of pain. So you should try to avoid that if you can.
Yeah, I remember 6 years ago, I believe it was maybe not my first, but one of the first interviews that I had for like getting a real job. And the interviewer said like the first rule of machine learning is trying not to do it. And of course, this was maybe extreme, but although it's true if you can not to, but sometimes there are solutions that you can do with like XGBoost, like I don't know, 50 trees that run in 10 minutes instead of building like extreme architectures that are very cool technologically, but would sometimes take the time to market will be months more.
Yeah, I think that like this kind of connects also to how we try to like advocate when we speak to customers or to potential customers or to people that are not even customers or prospects or whatever, but just are like getting started. The first step is try to build a pipeline that gets you to production with the stupidest model you can. Like if it's an if else, and always and the model just always chooses dog, and you get that to production, that would be, but you do it obviously at a fraction of the time. That would be better than taking 10 times as much and then deploying a neural network, because you might realize that either it's not valuable to anyone and you shouldn't deploy it to production, or you deploy it to production. I mean, the if else and always choose a dog maybe is a bad example, but if you have some, as you say, like very simple classifier that uses some classical model, runs much faster, needs no special hardware, et cetera, you realize that the baseline is better than the minimum you need. And so improving on that with a more sophisticated model that will take you 10 times as much is just not worth it from a business perspective. And that's hard to hear, I think, as an engineer. Like, I feel like so now I'm a founder. I'm a CEO. I'm not supposed to write code, but sometimes I kind of feel like I'm losing my mind. So in the weekend, I do write some code, and that's usually on something that I find is cool, and it might be useful. It might be useful in sort of a edge case or something like that. And I think that that's okay. Like, you should make time to do these things, but most of my time is spent on what I think would bring the most value to the business. And so I think it's like the Google 20% time. Only 20% is a lot of time to spend on something that's completely useless. Maybe 20% is sort of your free time if you do that, or I don't know, whatever, 10 or 15% of your work time on something like that. But most of it should be real business value.
Yep.
So another topic that you know a lot more about than I do is like ML in cybersecurity. So I think when we got started, the mental model of machine learning I had was either you take a table and you do linear regression or something like that, or you do some neural network for computer vision or NLP, or sort of some cool task that you have unstructured data for, and like it's hard for a human to explain why something is something, why a picture is a dog or a cat or something like that. And so you train a model to do that. But I had no idea how it was used in fields like cybersecurity. So maybe other people listening to this podcast don't know. And so what does ML in cybersecurity look like? Yeah.
Yes. So as you know, the word ML is an umbrella of like a lot of different terms, and similarly, also the word cybersecurity contains so much within it. So I specifically work in SentinelOne. We started as endpoint security, and now we do some cloud security and many other stuff. But then again, um, there are many different companies, specifically even in Israel, that do, like, I know, protecting many other things. And I know maybe something about like ML in endpoint security. And by endpoint security is basically what we used to call antivirus 10 years ago. Um, and and up until like 10 years ago, maybe 15, I'm not sure about the history there. But basically antivirus was like, there was like a huge hash map of files. Then you get a new file, you can create the hash for it, like MD5 and stuff, or stuff like that, the SHA-256, and then you get, like, I don't know, a string of letters. You could check that against a huge hash table. I'm not trying to diss on any cybersecurity people. Maybe I'm not like the most accurate, but that was basically what like antivirus software did. Uh, and
Hashing
then
functions made the world. Yeah.
Yeah, basically that. And again, it worked. And as we said previously, if it worked, then it was awesome for that time.
Yeah.
Uh, but then things became more complex. Like if you changed even like one bit inside some executable, then it's like a whole different hash, right?
Mm-hmm.
But if you
Yeah.
check it with some more basic stuff, like without even ML or something, but if you can create checks that would find out those are like the same files. So it's easy when you change 1 byte, but what if you change 10 of those or 100,000 bytes? And what if you reverse the orders and stuff like that? And those are also not the things that I'm very knowledgeable in, because that's like the deep cyber stuff. But basically what we can do now is trying to extract information about a file. Like we can say how many parts are in it, how many readable parts, how many writable parts. I'm not very accurate with the term parts. I forgot the term, like the executable binary terms. But basically, you can create many different, like how much, when was it signed, what thing compiled it, stuff like that. I'm trying not to be too specific. There's a thing called Yara rules, which are like compiled rules that you can run on a binary, and it said if the Yara rule matches something like, and I'm again not very accurate here, but imagine regex. You can run regex on a string, so you can run a Yara rule on a binary. That's
So this
conceptually
is like
what it is.
a rule-based system to understand what a certain file is.
It's something like it. And
Okay.
again, like my friends, the cybersecurity people would kill me for describing it like that. But that is how I understand it as like a machine learning person, because that is something that I can run 1,000 of those and then get like a binary vector, right? Once you get
Okay.
those, you have a lot of features. Then you can do machine learning, and then you can try and play with it with deep learning or XGBoost or whatever you want to play it with. So that's one aspect of like the endpoint security stuff. That's called static detection. That's basically what replaces the old antivirus. And then
Interesting.
what we have in SentinelOne, and this is where other companies are also going for, like this is the modern cybersecurity. You can check a file, like once something started to run, like maybe the file looks fine, and maybe like uh, it seems benign, and it can do like 99% of the time it is benign. But then once in a while it does something malicious when it's actually running, and that's what SentinelOne started with. Like that's what made the company what it is, and that's trying to find out things that are happening in real time on the computer. We have we try to call it AI, but like we have the joke that AI is just fancy if statements, and
Yes.
most of the like engine is basically that, but there are like very fancy if statements. Like the smartest people I know work on them, and I'm glad that I can call it AI, even though it's not like machine learning.
Yeah.
But on top of that, you can apply some machine learning, and we have some new cool stuff that I specifically don't not work on them, but we have some cool stuff that try to see actually the dynamic stuff and try to do some machine learning on it, and they work pretty good. And also, like the first thing you want to say, okay, if it runs all the time, then it's running live, then let's do some deep learning that understands and can predict in real time, like LSTMs and stuff like that.
Yeah.
And then actually also in most most of the cases, you again understand that if you do some basic
XGBoost.
models, they will give you like awesome results. And so we always come back to like XGBoost wins most
Just
times.
use X. So the takeaway from this episode is just use XGBoost, and only when it fails, then you graduate to the other stuff.
I think that's like
Apropos the rules of Fight Club. Yeah. You can find failure modes in which a neural network will have to work, but I think that like first rule of machine learning is you try to use XGBoost. The second rule is you try to use XGBoost, and afterwards maybe you try some other stuff. But yeah,
Yeah, I think we're trying to enforce deep learning these days on like everything,
yeah,
and maybe it's not always the best case. And I think like if your first go-to is not deep learning, like your first go-to would be deep learning if you want to distinguish something within an image or trying to do something on a like human language. That
Hmm.
the first go-to will be deep learning. But then if you have some specific business problem, I think 99%, and maybe I'm like exaggerating, but like 99% of problems don't do deep learning. Probably it will be okay.
Yeah. Yeah. I mean, I think we spent a bunch of time trying to think about why that is the case. I think there is some appeal, like the deep learning is more magical or seems more magical than other learning methods. So it's sort of like you throw it at a problem and you don't know what you're gonna get. It might be amazing and you wouldn't be able to expect it, right? And um, classical machine learning models are seem more deterministic. I don't know if I mean I think it's also objectively true, right? It's in all of the cases where it's basically like matrix multiplication with no nonlinearities. It's sort of more predictable, so less sexy, less of a reason to use it. But yeah, I don't know. We'll see what happens as you said in the beginning. And now we throw transformers at everything, so maybe transformers totally replace a deep learning as the concept, and you're like, oh well, I want to use a transformer for some random data type.
Yeah, although I think when I'm speaking to people not from the field about like deep learning or machine learning, I always try to, and again, you can find counter examples to the next thing I'm gonna say, but basically, deep learning is very good at like actually being human, uh, and that includes the positives and the negatives, right? So we're
Hmm.
trained deep learning today to actually distinguish between cats, dogs, boats, and like everything. But then you
Yeah,
wanted to explain like how did you find that? It doesn't know. But then
yeah,
also a human doesn't know, right? If I ask you how do you know this is a dog and this is a cat, you would just say, I don't know, I've seen enough cats in my time, right?
yeah,
So deep learning is very good at being human, again, also in language, right? Well, how do you know that this word come after that one? So if you're not from the field of researching specifically that, you don't know, you just do it. But then
yeah,
when we go back to business problems and you're trying to predict sales for the next quarter, that is something people are not very good at. And
yeah,
so deep learning is also, I wouldn't say not very good at it, because I've seen some examples that prove otherwise, but like it's not the first go-to use case to use deep learning in something that's like predicting the future and not um, trying to be human, like mimicking human behavior.
yeah. I would probably bet that also for those cases, the state of the art results don't come from deep learning. I might be wrong, but admittedly, that is not my specialization either. I think that I think it's interesting that the sort of the way you described it is the same way I think about like language for native speakers versus non-native speakers. So if you learn English in school in a non-English speaking country, they teach you a lot of rules for how you're supposed to say certain sentences and words and things like that. But so personally, I lived in the United States, and so when I got back to Israel and I had to sort of join class and learn there, but I was already speaking English as a native speaker, I didn't understand the rules. They were actually confusing to me. You just look at a sentence and you know if it's right or wrong. You can't explain that it's
Yeah.
like past progressive or something like that. I still don't understand those things. So I think maybe like we think about deep learning as superhuman, and maybe in a certain sense it is, but it's sort of more like an amplified human abilities,
Yeah.
whereas what non-deep learning methods do can actually be non-human, as you say. So that's an interesting way to look at it.
Yeah, I hope I'm not like pissing anybody off, because that's maybe like I'm not sure everybody would agree with that. Um,
Well, if we don't say controversial things, it's going to be much less interesting. So it's all good.
Yeah. Also, it sounded like I think in the past 20 minutes that I'm like dissing deep learning. So first of all, I'm a bit biased. I'm not doing actually like real deep learning in production and stuff like that. I'm not like the things I love about this field is not like I'm not a researcher, and I wouldn't go into like a research company that tries to find like the next big architecture, the next big loss function, or like optimizer. That is not what I do. Um, but I do love like im- deploying deep learning.
Yeah.
Uh, but I'm also like because I'm not going to do this for like the first thing that I'm actually trying. I have a lot of criticism against it. But when I think about it, maybe like my friends that do deep learning all the day are probably even bigger criticizers of the field. So maybe I'm not that bad.
You're not in the glass house, so you can throw rocks as much as you want.
Yeah.
Um, but that's actually like one other thing that I don't think we've spoken about ever in person that I'm actually genuinely curious about is like um, relating to sort of your experience with a bunch of different types of machine learning and research and things like that. Like, how did you decide to go into a career in like, or maybe not a career because you've done other things as well, but like, what led you to choose like, okay, I'm going to work on machine learning for cybersecurity?
It's funny answer. Just like I got in. I was looking for my next job in data science. I wasn't
Mm-hmm.
looking for the domain. Uh, I talked with my friends, like now I call them friends. Back then they were like interviewers. I just talked with SentinelOne. I talked with a like company that does vision for commerce. I've
Mm-hmm.
talked with something that's like fraud detection, and I just like SentinelOne the best, and that's how I got into cybersecurity. I'm not a cybersecurity person, not trying to be one, although again, some of the smartest people I know are coming from cybersecurity. Um, so, uh, but again, I didn't look for this specifically. I'm not sure if that's what I'm gonna do in the future. Uh,
So what led your decision? Do you mean like the people or something
yeah,
else?
the regular way you would choose a job. Like I thought this was the most promising company combining all aspects that like everybody would look for in a job. Uh, the trade-off between like what I like about the people, the product, the company, the compensation, all sorts of those decisions basically.
You also made a good prediction about the future with the sort of the IPO since you joined, right? We can talk about it now, right? Uh,
Yeah,
so
I've joined in a good time. Yeah,
that's timing is everything.
yeah.
Uh, so going back to the early days, what was the first model you deployed to production, and how was the experience?
Yes, I'm not the person with like the most straight up answers as you've understood by now. And that again depends how would you define deploy to production. My first model that actually got into like the product, I'm not sure what you would
Hmm.
call it, getting into production. By that I mean like I think it was 2016, which seems like not that long ago when I think about meeting my wife, but then it's like ancient history when I think about the field. Uh, and our basic way to deploy into production, I've worked in a company that's a search engine and a recommendation engine that try to do end to end with the customers to try to bring them the best social influencers. Um,
Hmm.
and we try to have something like a Google for specific search like influencers, which is something Google doesn't do until today. There are very specific fields for like people's hobbies. Like I know
Yeah.
um, like we've seen some very weird stuff I can't remember by now, but I don't know like fishing, but a specific type of fishing, and then you see a guy that's like has like 10,000 followers, which sounds like nothing, but it's 90% of all the people in the world that actually are enjoying that
Do that.
specific type of fishing. So
Yeah.
that's what we try to find. And then the way we deployed into production is that we got the model working on all of our data, and then we created a huge text file, which we then exported into Elastic. And Elastic did the magic of like combining it and doing the searching with like cosine similarity and stuff. So in today's standards, I'm not sure you would even call it like deploying to production, right? We created one file and then we told Elastic work on that. But that would probably something you would call like the first.
Yeah, no, I mean, I think that counts. The way I define production today is like if you have a model that actually makes an impact on real people or a real business and you're not just using it as like a show and tell, POC, stuff like that, then I would consider it production. And as you sort of alluded to, there are many ways you can deploy to production. I have a talk coming up about what production even means, in which I try to stay with a stricter and arguably more modern version of like wrapping a model and creating sort of an API that is accessible to either users directly or a product that calls that API to provide inference. But I think that what you're describing, again, like I think that this is sort of a thread connecting many of the things that we have discussed so far, is a simpler way to do it. Like you could do real time inference and come back with sort of the best result or something like that, but there are more specialized tools to do search, and so just filling up that database with the correct information is something you can do much more easily, still bring a lot of value without getting into over engineered solutions. So definitely, I would definitely count that as production. Do you feel that there were, let's say, significant changes since then? Like, if you were to go back to that same task today, would you do it fundamentally differently, or would it be more or less the same?
Um, Maybe like this is actually one of the specific case that deep learning will come in handy because we've done a lot of language processing. Um, but also I'm not sure if there aren't like because we deployed Spark like 0 point something. Today they have like I haven't worked with Spark for like 3 years, but it's in like 3 point something or 4 point something. And then we try to take the MLlib inside Spark and do some um, language algorithms, like the older generation of language algorithms. And I'm pretty sure that if I would try to solve this today, I could solve it in like the basic problem would be solved in like 2 weeks because there's probably some pip installed something, give me the text and it works. It works pretty good. Like of course, like there is a lot of features that the data science team could still create within those limits, but the basic search and recommend, um, I believe, like if you take some uh, package that sits on top of PyTorch and then maybe load some weights from the internet and just fine tune, there's probably something that solves this with like a month of work, maybe not 2 weeks.
You just gave me an idea, which is interesting. Like, if you look at state of the art solutions today, you're biasing yourself because Google has infinite resources basically to throw at any problem they want to solve. So, like, beating search at Google today is really hard. Still, people famously, Richard Socher, I hope I'm saying his name right. And if not, I hope it doesn't prevent him from being a guest on this podcast someday. But he is working on a sort of competitor to search on Google. But it would be interesting to see if like a single person could basically use a Wayback Machine to access the. I mean, I don't think it works that way, but like basically beat the original Google search a product with modern technology on their own. And it would probably be possible. It seems reasonable to me that that would be the case. So
Um,
yeah.
no, but the thing is, like, there's still a lot of place for like creating search engines. Just not like, don't try to compete with Google's. Don't search for like the entire internet, right? But
Yeah.
Google is not the best at this specific kind of problem. Give me that guy from Kentucky that likes to fish in this lake, and he's like the most famous person you know in his county. I don't know. I'm probably inventing that person. Or we found out that, like, there's a huge community of Russian women breastfeeding. And they have like very huge celebrities talking about breastfeeding. Uh, so
Interesting.
I'm not sure if I'm going into Google and trying to find like Russian breastfeeding. Uh,
Community.
yeah. First of all, I'm not sure it's even like considered safe search
Yeah.
in Google's terms, but it's a very legit community. Like, not there's not anything like not safe in it. It's
Yeah.
um, and you can find so many examples. Even if you go to like things like basketball, Google would give you like a first page result full of the LeBron Jameses.
Yeah.
But if I want to advertise some shoes, maybe I could give like the best high schooler in every uh, best like basketball player in the best high school in every county, and you have like a few hundred counties. You give each one of those kids like only the shoes, no, not even like even money. Just give them the shoes, and they will give you almost free publicity that would cost a lot less than LeBron James,
Yeah.
and maybe give you bigger impact. And I'm not sure Google can do this. They probably could do it if they wanted to kick you down, but they don't do it. And
They have better things to do with their time. Yeah.
yeah, so I believe there are many such use cases in the world for people to build search and recommendation engines.
Yeah, I think that there's this saying in entrepreneurship that if it's sort of a problem that is obvious and affects a ton of people, then Google will do it. If it's obvious and it doesn't affect a lot of people, then that's a great startup idea because the chances of Google doing it are small. You can actually own that market and then expand to similar markets, and then that's a good way to take over the world. And then if it's non-obvious and affects a lot of people, then that's probably for like really innovative moonshot companies. So maybe you're Elon Musk and you can go after SpaceX, but most people wouldn't be able to do that. And then non-obvious and small, that just means you're in for a world of pain. But it still could be a good idea if you're like a specialist, and the small amount of people can pay a lot of money. So
Yeah.
yeah. So if you have an idea that it affects a ton of people, then it's probably something that more resource intense organizations can take more easily than you can.
Where do
But
you think you've started?
I think that I think machine learning, definitely when we started, but still to this day, is not a huge group of people. If you compare it, like one of the things that we kept getting asked was what's the ratio between data scientists and developers, right? Because developers today, very clear to everyone, that's a huge market. Machine learning engineers, like the growth is staggering, right? Like it's growing very fast, but like much faster than growth in developers over the same years if you sort of count the start date of everything. But obviously software development has paved the way in many ways for machine
Yeah.
learning. We're standing on the shoulders of giants. So growth is very high. The absolute numbers are still not comparable to software development. And so I think that we're still in the range where if you're targeting developers in general, right, going specifically after machine learning practitioners and neglecting everyone else is not going to be worth your time and effort. Like you might do it on the way, right, but not as like the flagship thing. And so I still think, I mean, I'm obviously biased, but I still think it's there's a lot of potential for building really large companies. And arguably, like, now we're speaking in the future, right? Because when we made this decision originally was almost, well, now 3 years ago, I guess, or 2.5 years. There was basically nothing. Like, the largest companies maybe had a market cap of, like, whatever, um, 50 to 100 million, if I don't count, Databricks, which is like a data company, right? And things like that. So things were much much earlier in sort of in the life cycle, and it made even more sense. And now it's, in a sense, proven itself, because we do have, Databricks has grown ridiculously, Snowflake as well. They're not machine learning companies; they're still data companies, I think, first and foremost. But they have very strong machine learning offerings, and they're huge. So I think that that's sort of a case in point for startups can survive in those climates. But yeah, we'll see. We'll see. The future is still in the future. One other thing that I thought might be interesting for people to hear, that I think is unique about you, is sort of your social media presence. And I know you. You're a very humble guy, I think, in general, but you're very active on social media in many different capacities. Both, I think, in sort of humoristic or light ways, but also in, saying your thoughts and participating in organizing events and things like that. What drew you towards sort of the public, outward-facing side of things, and how has it affected your life, your career? Were you always like this?
I'm not sure I can answer that um, like with sound logic. I think that's just like my hobby. I enjoy that. I remember an old CDO of mine in like a previous company. He asked me, how do you find the time to be an influencer? And I told him, like, I don't watch soccer on TV, or soccer being like the most popular in Israel, but you can change it. Like, I'm not watching sports.
Yeah.
Uh, Doing social networks is just like my hobby. It always sounds weird when someone tells you Facebook is my hobby, because Facebook sounds like a just passing the time thing. But Facebook is my hobby. I have pages. I have many followers on my private account. I talk about things I enjoy, which is mostly humor, but then sometimes I talk about like science or the things we do. And the best kinds of posts are the ones that I combine the two.
Yeah.
Always thinking like this is not going to work, because how many people are going to understand this specific word game combined with this specific field in machine learning combined with this specific feeling you get when something happens in the office. But then those posts get hundreds of likes. So I'm not sure how this works. I found out that I have no way to predict if something's gonna work. I have things that I think are like very bad, but I need to get them out there, and then they get
Mm-hmm.
hundreds of posts. And then I have posts that I have that I think are like genius, and they have like 3 likes. So I'm not sure I can predict that. Uh, but basically, it's my hobby. It's just like what I do. I'm probably a very uh, public person, although there is today the introvert introvert extrovert thing that is very
Yeah.
popular, and I feel very comfortable in that category. Like, I wouldn't approach someone in a conference if I'm alone. I wouldn't approach anybody at first. But then if you
Mm-hmm.
just put me in the table with 5 people, tell me you guys are the group, you have to talk, then I would shine. Like people get to know me. So that's basically me in real life, and then it manifests to social media presence and everything like that. Um, I knew I wanted to give a talk even when I was a junior and had nothing to talk about. I knew that I wanted to be like that person on stage that could be affected maybe by some teachers I had in the past. I told myself I want to be that kind of person like this teacher was to me.
Mm-hmm.
Um, and giving talks is not like being a teacher, but it's the thing that most resembles that. Um,
Yeah.
and and then moving into like organizing conferences and hackathons, I think it's part of that. It's part of the framework of like being on one hand social and like public, and then on the other hand doing something that's actually affecting people's advancements. Um, that's the first
Yeah.
time I had to actually speak it into words. So
Ex-
thank you for that. I
ex-
think I've learned something.
happy to ask all the right questions. I I really relate to that. I think that there's especially now with what you said, like the distinction between introverts and extroverts. I saw a video about it today during lunch. I think that it's right to a certain extent, and I have always felt more on the extroverted side, and so that's why I enjoy speaking with people, speaking to people, and sort of formulating things in an outward facing way. There is a lot of discussion about whether or not you should do that, even if it's not in your nature, which I think is is sort of an interesting discussion to have, especially in the context of like career building. Like, do you think that even if it doesn't come naturally to people, they should sort of quote unquote get out of their shell and still post stuff, still talk at conferences, do things like that?
I'm I'm actually contemplating that questions this last few days or weeks, because I'm always encouraging people to give talks, and most people, like 90%, would say I have nothing to talk about because people are very shy. Many
Yeah.
people in our fields have like imposter syndrome,
Yes.
and they would say I have nothing to talk about. And then I'm trying to say it. I tell them something that Jeremy Howard once said in Fast AI course. He said something along the lines of like, you're not giving the talks to like the person you want to be in 10 years. You're giving to the talk to the person you've been 6 months ago, right? So you
Yeah.
think it's nothing, but it's not. After you do something for 6 months and you're a junior, it's probably not very complex scientifically. But if
Hmm.
you're probably the only person in the world that got your specific kinds of problems. And if you're doing something like, I don't know, how I did this kind of thing in pandas, and it's like the bread and butter of like every data scientist. So the junior would say, like the junior person would say, why can I give pandas talks to this kind of people, or probably a lot more versed in pandas? And I say you could, because they haven't faced the specific problem you've faced in the last 6 months. And probably there are more people who still haven't had those 6 months in the audience than the people who did. So in any
Yeah.
case, it's good for you. But on the
I
other hand,
would. Yeah.
I'm not sure you could enforce that. Like if it doesn't come natural for someone to go to a meetup and just like strike up a conversation with someone, uh,
Mhm.
I'm I'm not sure. Like there's this approach that says, but you still should, and then people feel bad because they're like going into the meetup saying I'm going to speak to people, but then they think, oh, I'm this junior. Why would I approach something with this and that? They're not sure about like how nice are people in the community, and they think, like I've seen some communities, and I think like data science community is like the nicest people I've seen in many communities.
Yeah.
But that's besides the point. So they come to the meetup and say I should talk to people, but then they talk to no one. But so the only thing you've achieved, that now they feel bad. And if you tell
Yeah.
something like you're good, just go to this meetup and everything's
Enjoy
fine. If you
yourself.
don't talk to
Yeah.
anyone, that's also fine. Just enjoy the talks, enjoy the pizza,
Yes.
and just enjoy yourself. And once that person enjoys themselves, they will see that like someone would go to talk to them, because it happens. The someone you sit next to, a conversation that we started like, where is this? I don't like the mushroom pizza. Where is the olives one? And then you start like talking about something, and then 10 minutes later, it just happens to be about data science. So it just happens. So I'm not into like I'm not encouraging people to enforce themselves. I'm just trying to motivate them to say like, it's fine. You will be fine. That's my approach. And then coming from a person like 6 years later, I think I can call myself senior, and I know I only lost my imposter syndrome, like, I don't know, after 4 or 5 years. So that would be fairly new. But as someone who finally doesn't have that, and someone who's a senior, I'm trying to be approachable, like even not when I'm
Hmm.
speaking, not in the part where I'm like, okay, I finished my talk, ask me questions, even later. And there's
Yeah.
one rule that I think I've heard on a podcast about Python called Python Bytes. Um, and they said something like, when you're in a circle, like 3 4 people speaking, like
Hmm.
leave a space, let another person join, because it's always the hardest joining in some conversation. But if
Yes.
people are talking in a conference hall, they're not talking about something private, about, like, I don't know, their kids developmental problems. You shouldn't join those kind of info. But they're not talking about that. They're probably talking about something in data science, or something about the pizza, or something about the hotels. Just join;
Yeah.
they'll be happy to. And I'm
Yeah.
trying to be the one who's like, um, showing in 0 words how I'm approachable, and just like, come speak with me, and we'll find a way. And that's also like, I'm also in that, right? Because I could sometimes be that person alone, and even if I don't have the imposter syndrome anymore, if I'm like, I'm the most senior person in the room, I'm not having the easiest time just approaching people I don't know. It's
Yeah.
easier when you see like 3 people talking, and they have a
I
little bit of space.
Yeah, I agree. I think I haven't fact checked this, so and I like to be data driven, so I apologize in advance if this is a lie. But I think that I saw a statistic today that the best predictor of creating relationships is physical proximity. So if you just go to places where there are other people enough times, you're very likely to end up making connections that you didn't have before. So that relates to your first point about like just going to meetups, and doing it more than like a one-off thing. Like even if you went one time and you spoke to no one, go again, and you'll probably start speaking to people by the third or fourth time that
Yep.
you do it. For us, like this was a very important part, starting the startup. Like we felt really out of the network. We didn't know too many people in the startup world and the machine learning world. Like we had a few friends, and that was it. And so one of the best decisions, and I'll give some kudos to Google here, is we signed up for the Google Campus for Startups, which was basically like a coffee place that Google runs and lets you come to work out of. And there are no prerequisites. Like you don't need to raise money. I think the prerequisites at the time, I don't know if it changed then, was like you need to have a technological startup you're working on, and it needs to be more than like, bro, I have an idea. Like you have to actually be working on something, and then you're surrounded by other people that are in the same stage as you are. Like they have a tech idea and they're working on it actually. So that formed a ton of connections that some of them are like still very strong to this day, and have been really impactful for us. And I think you can extrapolate um, to sort of machine learning or any community that you want to be a part of. Another point I'd like to make is that sort of about the imposter syndrome and having something to say. This is a sort of a meta anecdote, but this podcast, I've had the opportunity to bring in a lot of really smart people that have a lot of experience and probably don't suffer from, most of them don't suffer from imposter syndrome. But one of the things that I noticed is that many times I get feedback from other practitioners that they learned something from someone who's an expert not in their field. So
Yep.
many times, like that 6 months experience that you got, maybe there's someone who's not working on similar problems to what you are, but they are sort of, you hear about some solution that you've applied in your specific case, and with some slight modification, it can be a game changer for them. Specifically, like I have a specific idea in mind. I won't use the name of the person because I didn't ask them for permission to out them here. But I had the conversation. The second episode of this podcast was with Julian from Hugging Face, which is at the time, they're still to this day more focused on NLP. And at the time, I think they had no solutions for other types of machine learning models. And very well known computer vision researcher reached out to me afterwards saying that the ideas that we talked about for deploying NLP models really impacted how he thought about deploying computer vision models, which are technically not the same. They have different problems, different
Yeah.
data, different processing, but it was still helpful to him. So I think you can, again, extrapolate from that to many other cases. So you should value your experience more than you think.
Yes, and there's a very famous comic strip, I think by XKCD, but maybe it's someone else, that's showing like this circle and says like this is human knowledge, and then when you're doing a PhD, or you can translate that into like you're doing research at work, then you have like a small minimal blimp in like some specific place in the circle. And
Yeah,
most people, like you're the top 1% in the world about that specific blip, but then the circle is so large that you can always learn something from everybody. um, and then again, if it fails, you come to the meetups, you don't learn anything, you're not managing to speak to everybody. Still, free pizza is free pizza, right?
true, true. That's the real takeaway here. Okay, so we'll do a few like shorter questions to finish off that I like asking most of the guests. So, what is the most exciting, or what are you most excited about in machine learning and or MLOps right now, and why?
So I think there's something that is currently not considered like the same, but I think they're very much alike, and that's basically having things that are like Lego bricks that you can connect. And by that I mean, um, like everybody can deploy um, like like Dolly One or like Mini Dolly or this thing they have in Crayon AI.
Mm-hmm.
Uh, if you have like one GPU, you can deploy something like that. I think you can deploy Stable Diffusion
Yes.
with one GPU. I'm not sure how much time it takes to synthesize the image, but you can deploy it. And why can you deploy it? Because you have packages that you just like import this and then give me a model. The string name is Stable Diffusion, and you just get the model. And when you
Yeah.
combine that with something like, okay, so now I want this model to predict something within Redis, sure. So you can just like Docker compose Redis, and you just have Redis inside the computer. You don't need, like for the basic stuff, you don't need a DevOps person to just get something running. And
Yes.
that's of course a blessing for the DevOps people because they get to do more interesting stuff, but it's like a huge blessing for us. You can
Yeah.
create an application, like a very complex deep learning application with the UI, with the backend, with the model, just by like Lego bricking all the components and have like this huge Legos structure with minimal effort. And I'm very excited about that. I think officially people are not like the model repositories and like the Docker Compose repository are still not considered like the same field, but in my mind, it's all Lego bricking.
Yeah. Yeah, Lego bricking is a good terminology. I'll say, um, I totally agree. I think this is going to be the second episode in a row where someone says that this is the most exciting thing in machine learning right now. I think composability and modularity is like an amazing concept, and everyone who's done a get started with Docker tutorial sort of immediately gets that magic. The fact that you can with a tiny amount of lines of code or commands can get a system that is basically spec'd to what you want just running is crazy. And so maybe the takeaway I have from this is if you are one of the people building out systems, investing time in making them composable and integrated with other systems that already exist is a huge value, not just to yourself, like if you're building a product, but to other people because they can use it as a Lego brick.
Yep.
So also, I share that excitement. Okay, so second question is: tell me something true that few people agree with in machine learning or MLOps.
Yeah, I thought about it. So I'm not sure if um, I think most people would agree with like the the theory of the sentence I'm about to say, but most people will not be brave enough to actually do something about this. And the phrase is, "You have too much data."
Interesting.
And yeah, it can make some people angry, but I think like we're collecting a lot of data. Every company, like, go to a conference of every company with a booth will tell you we are using a petabyte of data, of event data every day.
Mm-hmm.
Um, okay, but what happens by then? You have like 300 petabytes a year, and what are you doing with it? And for most use cases that I've heard from people, like they have that in store, and maybe if someone asks for that later, they need this specific date, this specific event, because they need to check that something happens.
Mm-hmm.
Um, that's like that's the most common use case I've seen for that. Most of it is not used for deep learning, right? Because if you want to do, or machine learning in general, right? Because then you want to do 300 petabytes of data. How would you deploy it? You need something like Spark with like 1,000 nodes, and then this becomes a problem. So you find yourself trying to work with smaller data, and in any way you look at it, it's a problem. So if you have to legally keep that, archiving that, that's one thing. But if that's a point for your company uh, to be proud of, that you do like 1 petabyte of data, event data a day, I'm not impressed. I don't believe most of the companies that have that need that.
Mm-hmm.
Um, Maybe they could manage with something smaller.
I think maybe a finer. So you phrased it in a way that it's a good answer to the question. It sounds controversial. I
Yeah,
would say that maybe a finer way to put it is, when you're starting out, you usually don't have enough data, and later on, you usually don't have enough good data. And sifting through petabyte scale data to find data that is actually useful for you to sort of improve your model on is really hard. I think many of the large scale sort of the companies that deal with very large scale data. And again, I'm speaking about the areas that I feel more comfortable in and know more about, which are, I think, the areas where less companies are actually in it, right? So most of the companies that have petabyte scale data, probably it's like tabular data, events, stuff like that. If you go to Tesla, right, or any of the self-driving cars,
yeah, of course.
the hard part is finding hard examples within those petabytes of data, so that you can actually improve your model on the edge cases. But you don't, maybe Tesla does, but I think most companies don't actually train on the entire data set in any context. So you just have different data problems, and I totally agree with that. I think that maybe if I had to answer the previous question, I would say that the most exciting thing in MLOps right now is sort of active learning, because that's sort of paradigm that's supposed to help us deal with having too much data. Like, how can I take out the examples that actually matter and train my model on those? And then you have this whole other issue of, how do I improve my model without forgetting the stuff that it was originally trained on? But yeah, I think that's a well phrased answer. So
I got my
last,
daughter a
yeah, sorry.
new bed yesterday,
Okay.
and I've built a new bed, and then I need to take out the old bed. So I'm removing the bolts and keeping them on the table. And once I've thrown away all the parts that I didn't need, but then I had this like huge lump of like bolts, and I
Hmm.
like, and then I asked myself, do I need to throw them away, or maybe in 2 years' time I will have this specific thing that I need to connect to this specific thing, and maybe this will be the perfect bolt. And that's stupid, right? Because if that thing happens, then I'll go to the store and for like less than $1 buy a new bolt. But then I'm not bringing myself to actually throw this away. And I think that's how most companies treat petabytes of data. Like, because maybe somewhere in the future we'll need the petabytes of data, and maybe you would. I'm not saying you won't, but most won't. Again, if you're Tesla, you're Google, it's something else than if
Yeah.
you're doing something.
Yeah, but you are not Google. That's true. And also, I guess that's a great that's a great analogy. I think there's also Murphy's law at play. So if you throw them, then you will need them eventually. If you don't, then you won't. So you got to decide, right? So the best
You
thing
know
to do
what?
is just
When it
store it so you
happens,
never need it.
yeah, and the thing is, like when it happens in 2 years' time, I will tell myself, well, I have those bolts somewhere, and I need to invest like 2 hours looking for those bolts, or maybe just one day after work, I'll go into the store, invest the like less than $1 thing, and buy that. And now I've got like
Yeah.
I've wasted storage space for the old ones. I didn't use them. I bought the new one, so like I didn't do anything. So just like you can throw stuff away.
Fair enough. You heard this here first. We will call this data minimalism. So you don't need data. Okay. So last questions, I guess. Question, I guess, is what are your recommendations for the audience? It doesn't have to be data science related.
Yeah, so I specifically think of like not recommending data science related, and I think my best recommendation is more holistic than something specific. And then that's like try to watch even like one television show in real time. And by that I mean like we have the binging culture is very like popular these days, and this is how I consume most of the TV shows I watch. But then
Hmm.
once in a while, I find a TV show that I watch from episode one, waiting for episode two, and then it maybe not the best TV show. Um, it's not perfect. There are many more that are like better than that show, but there is something about maybe watching that TV show on the course of 10 years when the show itself is 10 years that that's like on the final episode, even if it wasn't the best show, you get like a very specific feeling that you just can't replicate when you're binging a TV show. So maybe the next time you're seeing a new TV show, like new TV show coming up, watch the first two episodes, and if you like it, just keep on with it every week.
That's an interesting tip. I don't know why, but the first thing that came to mind was Game of Thrones, which, in my opinion, that I know is shared by many people, ended horribly, but there was still something satisfying about it because we've been watching it for so long, and now there's a spin-off or prequel or whatever you want to call it. So I'm watching that. I enjoy it, and I'm waiting for the next
I
episode
enjoy
every
it.
time. Yeah.
Yeah, but I can give you an example. I watched a show when I was in the university. On my first year, there was another show that started about a university, like the sororities and fraternities in some invented college. It was called Greek. It's not a
Hmm.
very good TV show, but I've watched it every week, and it was heartwarming and it was nice. And the main character was like a geek, like I felt. Uh, and then it finished after 4 years, like those same 4 years of college, and it does something like you've grown up with them, and it's something that like it sounds very cliche, but it's actually the truth, right? You've grown up while they've grown up. And then if you
Wow.
take that into like Modern Family, I watched from episode one, and like I've never binged it. And then when it
Wow.
closes up 11 years later, I started that show when I was in university, like, and then I've had
Yeah.
like 7 years of military service. Then I've joined the tech world, and all these things happened in my life. And then when that character started, like the kid was like 8 years old, now he's finishing college. um, you actually understand how time passes, and you can't replicate that with a binge, although you should still binge Modern Family sometimes if you haven't, because it's a very funny show.
Who's the best character?
Probably Phil.
That was
Now,
going to
now
be my
being a
answer.
dad, I'm even more feel the guy. But even before that, I think like he's the funniest, and I've always been the personification of a dad even before I was a dad. So yeah, I dig that person.
Yeah, definitely. Okay, so I'll make one data science related recommendation, which is where we started. PyData is happening pretty soon, December 12th. Am I correct?
13th.
13th, almost. So coming up, you should totally attend. You should totally submit if submissions are still open by the time this episode is out. And yeah, we're probably going to be there as well. So we'll see you there if you join. And Dean, thanks for joining me today. It was a pleasure to have you on.
Thanks for having me.
And thank you all for joining, whether it's on YouTube or your podcast apps. See you in the next episode. Bye.
Bye-bye.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again, and see you next time.